The overall goal of this procedure is to fabricate soft gripper devices using a rod-based approach, combined with 3D printing and soft lithography techniques.
This method can help answer key issues faced in the fabrication of soft pneumatic grippers, such as channel occlusion during the sealing process and the incorporation of an air chamber.
The main advantage of this technique is that it allows us to build miniaturized pneumatic channels within the soft gripper structures to ensure consistent actuation.
The implication of this technique extends towards nerve anastomosis surgery because the soft robotic gripper permits delicate nerve manipulation without overgripping damage.
We first had the idea for this method when we faced difficulty developing functional soft gripper using conventional casting sealing process and started experimenting with thin rods in the casting phase.
Begin with weighing out an equal mass of the two component materials for the elastomer in a mixing vessel. Then cover the container and load it into a centrifugal mixer along with a balancing mass. Now run a 30-second mixing cycle with the mixing phase at 2000 RPM and the de-aeration phase at 2200 RPM. Expect that the thoroughly mixed components will now cure uniformly when molded. Note that the design and production of the molds is covered in the text protocol, and the next section deals with their use. This process